Okay, do you want to start the quiz?
Yeah.
Sure.
19 questions.
Yay. Hmm. Actively
How many
participate.
questions?
19 apparently.
Oh, wait, actually, it scrolls down.
Wait,
34.
what?
We have 34.
Oh, we have 2 pages of it. Wow.
Hmm.
Well, this is gonna be fun. Oh, this looks exactly like uh well the first few questions do, like the preparation.
So, do we all have the same questions then, I presume?
I believe so. Is number question 2, which of the following variables is slash are categorical?
Yeah.
Yep.
Yep.
So I bought randomly selected brand of toothpaste at a convenience store.
Yep. And the other two are numbers, not really categories.
Yeah.
So I just say B was the answer.
Okay.
An IQ test score in the United States is 120. So,
Oh, yeah. So
so
this,
I would have said 100 is a statistic, 112 is a parameter, right?
112 is a statistic.
yeah.
Oh, so it's
A
reverse.
statistic.
Yeah, so
Wait.
I got this one wrong in the exam. So the parameter is like the
Oh, hang on. Don't go talking about the exam. Remember,
Yeah, that's not good.
oh
we're
yeah.
recording this.
Well, I
So
was just saying that I wasn't going to tell you what it was. I was just going to say that you need to know this for the exam.
Got it.
Um, but yeah, I think like the parameter is like the original, like the initial study, and then when somebody takes a sample from that study, it's a statistic.
Oh, okay.
Does that make sense?
Yeah.
yeah, I mean, that's what I was gonna say. Is 112 is a statistic,
Okay.
and 100 is a parameter.
Okay.
Right. Gotham City has 4 distinct neighborhoods. Property values. I would say a stratified sample.
Yeah. Just
Hmm.
because you basically like, because they're going to fall into it. Each one is going to fall into a category, either high or low. And you take a random sample from there.
Yeah, that makes sense, where it divides the population into a subgroup
Yeah.
and then takes a random sample from those groups. Okay, that makes sense.
Yeah. So yeah, it's a few people from each group.
So it's a stratified.
Yeah. I'll
Yeah.
be right back.
So I'm going to say a stratified random sample for 5.
It's what?
A stratified random sample.
Okay.
Well, stratified random sample isn't. Um, well, it's redundant. It's a cluster, I think.
I thought it was. Oh, okay.
Because if you notice, it's not the same as number four. So number four, they take a few people from all the different groups,
Hmm.
but in number five, all their subjects come from one subgroup.
Okay.
So it's a
Oh, okay.
cluster sample.
Yeah, because they're not getting. I guess they're not like comparing them. They're just getting one group.
Mm-hmm. So cluster for number 5.
Yeah. Single fundraiser, the name of every person who attended interest. This one's pretty simple. It's pretty. I think it's A, isn't it?
Yeah, simple random.
Simple random sampling, because we're not clustering into groups. It's just everybody in a random sample from it.
Yeah.
Right.
Yeah.
Oh yeah, simple random.
Okay, so we have 2 groups, and then they take a random sample from each group. Isn't that stratified sample?
Yeah.
I think so.
Yeah, because that's what I was saying with the other one. Like, I think you're right, David, but that's why I was saying like strat or simple, whatever it says, stratified random samples, because stratified means just to break it into 2 groups that are similar, and then you take a random sample from those 2 groups.
Right. Okay, yeah.
So I was just saying, like, I think you're right on the previous question, but I don't think stratified random sample is redundant. I think that's just more specific.
Yeah. Wait, so do you think that's the answer for
Yeah, because I think that's the answer to 7, because Democrats are put with Democrats and Republican are put with Republicans, so they're similar.
right. Yeah, stratified. I agree. Right.
Okay, I can't open it.
Dang it. It's because it's an SPSS file again.
Is it this? Oh, actually, which question is it? No, question 8.
Hang on, let me open up the software. Usually takes a minute. All right. It's weird. Maybe check to see if there's a Crossroads purchases file for Excel in the textbook.
Will not
Or,
open for you either.
huh?
Will it not open for you either?
No, I think it's opening. It's just moving really slow.
This is the Crossroads.
It's like frozen right now.
This page contains data. Crossroad purchase, as I found one for Excel. Do you want to? How do you put it up on the screen?
As in
This screen right here, the video.
oh, how do you like share your screen? Is that what you mean?
Yeah.
If you move your I'll share my screen and show you.
Wait, what?
You kind of share your screen, is that what you're talking?
Well, this is my entire screen, but I can't minimize
Oh,
my call for some reason.
Okay, I got it open.
okay.
Let's see. The mean of the amount spent.
Oh, wow. Let's see. I have the amount, like a ton of amounts here, but I don't have a mean.
So it'll want the mean and the standard deviation as well.
I'm just trying to.
So for the mean, using the software, I got 4.771. And
What did you get?
4.771.
yeah. And then 1.912 for the standard deviation.
Okay.
So you were able to figure it out on that?
Well, it says use the software, so I assume that there's a way to do it pretty simply.
You have to make a histogram.
Interesting.
Yeah, it was for the.
Let's see. And then it says create a histogram.
Or I did create a histogram. It looks like it's from the exam review. Or actually, no, it's not. Yeah, question 10 on the exam review is create a histogram of the amount spent on the Crossroads purchases.
See, I can't make it because I can't make a histogram. I don't know how to get it.
Huh?
Do you know how to get the information? That file that won't open, the Crossroads purchases.
Oh, you have to, if it has a .sav next to the file name, that means it's for SPSS. So you have to purchase and download SPSS.
Oh. So is there a way to do it otherwise?
You can get it through Excel.
Yeah, you'd have to look on Excel.
Yeah, you can go to the lesson 8 review for exam and click on the link, and it'll take you to a bunch of Excel formats where you can download it from.
Oh, okay. Where is the link, did you say?
It's in a lesson 8 review for exam.
Yeah, whereabouts in that?
It's question 8. It's like the line right below that where it says open data file Crossroad purchases. And you click on it. And then you scroll down to where it says Crossroad purchases.xl. Or
Oh, okay. Okay. I made a histogram.
Mm-hmm.
Okay.
So I guess click the button when you're done and then use the next question.
Is everybody there?
Yeah. Jessica Mayer and her research team.
Yeah. So what goes in table A?
What was the mean, did it say?
Square deviation.
Do we have to work out the mean, or?
So I think you find the mean of the 4 temperatures
Yeah.
first.
Okay, so it's a regular temperature minus core temperature.
Yeah.
Okay.
So yeah, I think you find the average of the 4 temperatures,
Mm-hmm.
and then yeah, do x minus the average.
So I get the answer. B for A. 0.165.
0.165. Yeah, me too. All right, I got negative 0.165.
Yeah, sorry, I mean negative.
38. It's 38. So it's 37.1 or 0.91 minus 38.075.
Yeah.
Okay. So yeah.
And then for B,
Just do it again. What was the average of those numbers? I worked.
For 11, did you guys get negative 0.165?
Yeah.
yeah, negative.
Negative, yeah, that's what I said. Negative 0.165.
Mm-hmm.
Oh,
With
yeah.
the value that goes in the position with a V in the table above. But it says squared deviation. Does that mean we have to square it?
For A or B?
For question 11, for A, it says,
No.
oh,
'Cause
marked
that,
at the position. Okay, so it's the first one. The second one is squared.
yeah, the
Okay.
second one we square the answer.
Okay. 7.538.075. And then you squared. So I got negative 0.68, rounding up 1. Negative 0.681.
It's positive because it's.
Oh, it's squared,
it's
of course, yeah. So it's 0.681.
Yeah.
Yep.
Okay, what quality is equal to the sum of the number in the standard deviation column?
Um. I don't think it's any of them.
Yeah, none of them seem right.
So that's not the formula for a standard deviation.
Yeah, I don't know what it is.
I think it's D.
Let me just check. So I get the calculation of the means of the sample, or standard error of the mean of means, deviation or errors, sum of squares. So I'm not really telling me much. Yeah, I don't think it's any of them. Oh,
Yeah,
well,
that's what I put.
I think it's variance. So it says in probability theory and statistics, the definition of variance is either the expected value or average value of squared deviations from the mean.
Wait, say that again?
So I looked it up online. It says in the probability theory and statistics, the definition of variance is either the expected value or average value of squared deviations from the mean.
For that, of the square deviations or the deviations?
It's squared deviations.
Wait, is it the sum or the average?
The average.
Okay, because this is asking for the sum.
Okay.
Okay.
Ah, man, they almost tricked us.
So it's none of these.
So yeah, if it asked for the average, then it would be the variance.
hmm
Um,
But none of these are correct.
it's just asking for the sum.
Okay, what is the standard deviation of these?
Okay. So take each number, subtract the mean by the square result.
So I'm just gonna put this in Excel, number 15.
Yeah.
Wait, number 15? Or number 14?
Or 14.
I have 0.619.
I got 0.715.
I'm just finishing it right now.
Let me make sure I entered them.
So we got
In right.
37.91. Let's see. 37.91, 37.25, 37.25, 38.98,
What did you get the standard deviation to be?
and then 38.16.
I got 0.715.
I got 0. Where is it? 619.
How did you find it?
Okay, I went on the Excel and tried to figure it out.
So I got the standard deviation is 0.715. The population standard deviation is 0.619.
Oh, okay, never mind then.
The population standard deviation.
Yeah. So it basically from a sample, we can work out the variance, and then it can work out what the population standard deviation would be.
I must have used the wrong formula.
I don't know, maybe.
Yeah, there's like 5 or 6 standard deviation formulas. It's kind of annoying.
Okay, so which one is 0.7 what?
715.
Okay. Yeah, there are a lot of standard deviations.
David in the short
Hang
code.
on a sec.
I think it's going to be funny. I feel like in a year I look at one of you on campus and I'm like, how do I recognize that guy?
Okay, under certain conditions, a standard deviation can be negative.
That's false.
Mm-hmm. You can have a negative standard deviation.
Okay. Number 16.
So we're looking for the smallest standard deviation here, right? So we're looking at extradural.
Which
Most consistent temperature.
Isn't that
Yeah, I would
consistency equals a smallest standard deviation?
yeah, I'm going to say B.
I would say so.
Unless the size wants it. Because that one's
Well,
only.
no, because
It's not the highest temperature. It's like, I mean, standard deviation is like how much it's going to deviate from the mean. And so B is going to deviate less.
Yeah, I was just looking at the size that was taken. Like, you have 6, 3, and 4. I don't know if they want us to do something with that or not.
That's just the sample size.
Okay. So, yeah, the one with the smallest deviation is B.
yeah, I'd say it's B because a smaller spread with extradural.
Mm-hmm.
I can define standard deviation in my words.
Yes.
Sure.
Yeah, sure. Of course I can. Why wouldn't I be able to?
I get 18 to be 75.
Wait, what?
You got what?
18 on 18.
8 for 18?
No, 75 for 18.
Whoa, where'd you get 75?
Yeah.
What is the third quartile? What it's asking?
Which is a third quarter?
Yeah, so what's the value of the third quartile? So it would be 8.
Oh, the value.
8. Okay. It's like, yeah, no, 75%, but
8.
yeah. I think number 19 is more what you were thinking of. Or what percent of the data lies between 4 hours and 8? So isn't that 50%?
Yeah, because between the 25th and 75th percentile, so that, yeah, it would be 50%.
So 18 was 8, yeah? Everybody got
18 was 8, 19 is 50 for 50%.
okay. Oh, it's really annoying that we have to go on the next page right when we have information.
Yeah, okay. I'm sorry. Yeah, I'll write it. I'll just write it down.
All right, so next page. Estimate the mean of the measured height. Dang it, so now I have to go back and...
Yeah.
Okay, I wrote it all down. I wrote it down.
What is it? It's 2 minus.
It's well, to get the lower, so hold on. Estimate the mean of the measured nitrate concentration of drinking water. So we have the mean. Estimate the mean. That means a U, so we have a U. Yes. Is standard deviation. Hold on.
U minus 2, okay.
That makes sense, okay.
Okay, so I found the average of 1.59 and 2.52.
Oh, so you just added them together.
Yeah, and because that gives you the middle number between those two.
Yeah, it gives you the average.
It's 2.055. That's what I got.
.055 is
Okay, so
Mm-hmm.
I'm just looking at this. I got the standard deviation to be, hold on.
Are you looking at the mean or standard deviation?
I'm looking at the standard deviation,
Okay.
but I'm not sure if it's right.
I don't know how to estimate the standard deviation.
I was
So
thinking like it's 1.027, but that doesn't, I don't know if that makes sense. Or yeah, 1.0.
So what I did, once I got the mean, I subtracted 1.59 from the mean and divided by 2.
What'd you get for, is that your answer for the standard deviation?
Yeah, for standard deviation, yeah.
So what was, I got 1.0275. What'd you get?
I got 0.233.
Okay, so I'm way off.
What did you have as the mean?
I didn't figure out the mean yet.
Oh, yeah, you have to do that first.
Well, I was just using rig kind of algebra technique, but it didn't work very well.
Yeah, you need the mean before you get the standard deviation.
So did you hear how I got the mean?
No.
So I just took the average of the two numbers that it gave us in the question.
Okay.
1.59 and 2.52.
I was doing like reverse algebra, trying to figure it out. Wait, where is it? Oh, that's where it is. So yeah, we had the mean minus 2 times the standard deviation is equal to 1.59, and then the mean plus 2 times the standard deviation is equal to 2.52.
Mm-hmm.
So what I did was I was trying to figure out what the standard deviation was by just using some algebra, but I guess it didn't work very well.
Yeah, 'cause what it's saying is if you add 2 standard deviations away from the mean, it's 2.52. If you take away 2 standard deviations from the mean, it's 1.5.
Okay, that makes sense.
That's not actually like a 2x or a 2y. It's just kind of symbolizing that you're moving on. If that makes sense.
Okay. So what was the mean of it again?
2.055.
And the standard deviation?
I got 0.233.
Okay.
Do you want to hear how I got that?
Well, if you just plug it into the formula, you'll be able to figure out pretty easily. So
Well, I didn't quite do that. I subtracted. You just subtract one of the values it gives you from the mean, and then divide it by 2.
well, yeah, that's what I mean, put it into the formula.
Is that the formula?
Well, it's the standard deviation minus, or the mean minus this 2 times the standard deviation is equal to 1.59. So if you just have the mean, and then you just do simple algebra, you'll figure out the standard deviation.
Right. That's right.
Well, I thought you made up a new formula that would revolutionize mathively. No,
No. It was basically just taking the two formulas and like finding the value of u, like u is equal to n, or u is equal to 2 times the standard deviation plus 1.59, and then you plug that into the other formula, and you'll be able to find out what the standard deviation is that way.
So we all agreed then on 21 is 0.233.
Sure.
Yeah.
Does it work for the other one too?
Huh?
Does it work for the other formula too?
Wait, what other formula?
It's a mean plus 2 times the standard deviation is equal to 2.52.
Oh, yeah.
Okay.
No, 2.233. Yeah. I see what you're saying. Yeah, you're right.
Okay. Okay. Then you have no arguments for me. Between what two measurements measured nitrate concentrates to approximately 65 a day lie? So this is a 68, 95, 99.7 rule. So we need one in the standard deviation. We just need to figure out the standard deviation one time, right? Or no? Yeah, one time.
Right.
So subtract the standard deviation from each side one time, and we'll have the answer.
Right.
Okay. 233.
So I get the answer to be D.
Me too.
So we have 1.356. Okay. Wait. Which one did you guys are thinking of?
D.
So 1.823 and 2.288.
So you just take.
You just you just subtract the standard deviation from the lower side and add it to the upper side, right?
Yeah.
And we estimate the 2.055.
Okay. Okay. Let's use that then.
Okay, so 23. What is the value of a standard normal distribution?
Okay, can I ask something for question number 22?
Yeah.
Okay, you're saying it's D, right?
Yeah.
So the upper value starts with 1.59, and then you have 2.52. And then when you apply the 68 rule, aren't we just subtracting the standard deviation from 1.59 and adding the standard deviation to 2.52?
No. Those two numbers are two standard deviations away from the mean.
Oh, okay, that makes sense. So we need to add a standard deviation. And subtract. Okay, that makes sense.
Yeah, like your mean is right there, and one goes one way.
Yeah. So
Okay, now I understand it. I forgot. Yeah, sorry, two standard deviations away.
right.
Okay, I got it now.
So what is 23 asking us?
What is the value of the mean of the standard normal distribution? So it's a word?
It says of a standard deviation. So it's not. I don't think this has anything to do with the previous questions. It's just asking in general.
Oh. What is
Oh yeah, it's Wait. Right.
What is the value of the mean of a standard normal distribution?
So I'll read this sentence here. It says a normal distribution with a mean of 0 and a standard deviation of 1 is called a standard normal distribution. So is the mean 0? Because it's normal?
Yeah, I think so, because if you look at the probability applet.
So is 23 0 and 24 1?
I think so.
I think that's what
Why is there
saying.
a spell check next to it, though?
I guess we just have to type it in.
Like Z0?
Yeah, I wrote it in.
Huh.
Are you sure?
What is the value?
So there's like a spell checker thing. Am I sure about what? That it's 0 and 1?
No, about having to type it in.
You can click on the ABC button and it says no misspelled words. Speller check. So
So a standard normal deviation.
Because it just if it's normal, it means that they're all like the same value. So it would be like saying if 5 different categories all had the value of 5, or if basically they would all, you're dividing like 0 by itself.
Yeah, standard normal deviation. A normal deviation with mean of 0 is what a standard normal deviation is. So that's a value. But does it want us to type out 0 instead of just type out 0?
I don't know. That's what I did. I don't know. What does everyone else think?
I don't know.
I just put in the numbers.
Why is there a spell check on? That's what I don't understand.
Well, we'll have to argue it out if it's that reason.
Yeah.
Let's cancel. Okay, whatever. 0 and 1. What's the value of standard deviation of a standard normal deviation? What is the value of a standard deviation? Okay.
1.
Yep. Should be There's a probability that a randomly selected student will score above 5542.3. So that's the upper value. So let's see. 42.3 standard deviation of 150 point.
Is it? I think it's just 0.5. Or 50%.
We have to use a 68 rule, 68, 95, 99 rule for this? Or
Well, no, because 542.3 is the mean.
yeah,
So,
okay, so it's 0.5.
Yeah, half will be above, half will be under.
It's probably the random selected student will score below 600 on the GMAT.
You just put that into the Z-score or whatever.
The applet.
Yeah.
What's the formula for the z-score again?
X minus U over the standard deviation.
Yeah, that's it. So 100 minus.
So 0.478.
And then we have to find below that, right?
Yeah, so I
Right.
have no probability. Let me know when everybody
So
else.
I have it.
So I got 0.684.
That's what I got.
0.684.
Yeah, 0.684.
Yeah. Let me just look at this.
And then it asked for above that number 2.
So 0.316.
47. Well, 0.316. So we have. Everything below that.
Did everyone get 0.316 for 27?
Well, 27 is the score above 600, right?
Yeah. So you,
Yeah, so you just highlight the opposite
Yeah, so it's
side.
just the right of it. So 0.316.
Yeah.
Zero point 0.684. 0.684. Okay, find the GMAT score that corresponds to the 10th percentile.
Does everybody know how to do this one?
I forgot.
I don't know.
So what you do is you put 0.100 into the probability, which will give you the z-score for the 10th percentile. Does that make sense?
Into the applet. So wait, 0.1?
So if you go up to the area and go 0.1000, whatever, it'll just make sense.
Okay.
And that should give you the z-score.
Yeah, it does.
And the z-score is 1.28.
1.282.
Yeah. And then, let me see.
Wait, never mind, okay.
So then you
Then put the 90th percentile.
get the u minus the standard deviation and multiply it by the z-score for the 10th percentile. That gives you the answer.
So, okay.
So you do
The mean minus the standard deviation, and you multiply that by 1.282.
The standard deviation, which it, so, okay, so 542.3 minus 120.54.
So what, 600 minus, wait, what was the u?
Didn't you say it was the mean minus the standard deviation times 1.282?
So it's the mean minus the standard deviation, and then you just put open parentheses 1.282. So like, let me see. Look at your screen for a sec. So it should look like that part right there. Does that make sense?
Yeah, didn't I say that?
Yeah, probably. I was just writing as you were. I was writing while you were talking. So
I said 542.3, which is the mean, minus 120.54, which is a standard deviation, times 1.28, which is the 10th percentile that we calculated.
Yeah.
What did you guys get for that?
I'm just doing it right now.
I got 539.853.
I got 540.696.
But that's so close to the mean, though. It's not going to be the 10th percentile. And I'm trying to look back through the old lessons to find the preparation assignment that had that formula.
Yeah. I think that's right. Maybe I'm wrong.
Hey, you know what? I know. I'm looking for the email the teacher sent me that had that formula in it.
Gotcha. Is it okay to bring
What?
recording home?
Yeah, lesson recording. Right, is she heading to the STC?
I don't know.
U plus Z.
Michael?
Is it
Man,
the
I'm
percentile
almost there.
is equal to the mean plus the percentile times the standard deviation? .3 plus 10, 120.54. No. 1.28. Okay. So I saw a formula. It was the standard.
Okay, so hang on. It's the z-score times the standard deviation, and then add it
the
to
mean.
the mean.
Oh, not subtract.
So yeah, so it's 542.3.
Plus
Um,
1.28 times the standard deviation, which is 120.54.
Negative 1.28
Why is it negative?
because it's in the 10th percentile, so it's you're looking at the lower standard deviation, not the
Oh,
yeah,
so
not the
I
negative
got
one.
388.0088.
Yeah, times 120. What'd you get?
388. Oh wait, z-score. Hold on, I might have messed that up. I had 388.0088.
Yeah, and it says round to a whole number, so
So
388.
388. That's what I got. What'd you guys get?
So what was it?
Yeah, 388.
It says 388. Is that what you got?
Yeah.
Mm-hmm.
Okay.
All right. Next, we have the 90th percentile.
That's weird because like I did the same thing in the exam and I got it right, so I don't know how I did that.
So, what about you guys? What about this one? The 90th percentile. Is that positive? 1.282?
I think so. Yeah, it is.
Okay. I got 696. Round up to 697.
Yeah. Me too.
I'll just finish another point. What did you say you got?
697 for question 30.
Okay. Yep. Oh wait. 30 or 29?
29 is 388. 30 is 697.
Oh, gotcha. What did we work out 28 to be?
Oh wait, I totally messed that up. Sorry. 28 was 388. 29 is 697.
Okay.
Yeah, whoops. I was misreading it. I don't know we don't know what 30 is yet. The first quarterly of distribution.
25.
Quartile.
It's just going to be.
I'm gonna go left right.
Dial.
Probably like anytime really.
Okay.
I don't have class.
Can I use this?
Yeah.
Oh, it's right. I don't need it.
So I think so. It's the first quartile, so you just put 0.25 in the applet to find the z-score.
Which is 0.319.
I
You put,
got negative 0.674.
that's what I got.
Cool.
Negative.
Wait, what did you put in the applet?
In the area, put 0.25.
Oh, that's so weird. I put it in the first one and it was wrong and I repressed it and it was right.
And we got negative 0.674.
Yeah.
Is that the answer?
No, I think we have to then put that in the formula.
Okay.
Yeah, so you put that in the formula.
0.674. Okay, I have 461.
Me too.
Yeah.
Then you find the third quartile.
Woohoo!
1. And then that's just 0.75 in the applet.
Mm-hmm.
And yeah, positive 674. So I got 624. Be rounding out.
You got 624. Oh, I put the wrong z-score in. Yeah, 624.
I ran it simple. So finding the z-score, or not. N equals 15, taking the z-score.
Isn't the mean the same?
If it's n equals 15.
Not if n is equal to 15, is that what you said?
Well, it's n equals 15. What number does it have to be above for the standard deviation to equal the mean?
It has to be,
Well, it just has to be normally distributed.
yes, that's why it's distributed or not.
So yeah, so it's the parent population is normally distributed. So
So
it doesn't matter what the sample size is.
It's the same as it.
So 542.
0.3.
542.
542.3. Is that what it is? 542.3.
542.3.
Okay. The standard deviation then.
What's the standard deviation of the distribution of sample means?
So it's just going
What's the formula again?
Is the standard deviation over the square root of n.
Oh, right.
Square root of n times is it the standard deviation times the square root of n?
It's the standard deviation divided by the square root of n.
Okay.
Example mean.
So we have 120.54 over the square root of
15.
15.
It's 31.123.
What'd you get?
31.123.
Yeah, I got that. 31.123.
So I got this standard deviation. Is that what you just said?
Yeah, 31.123.
What was it?
31.123.
Okay, I must have done something wrong.
Well, it's a standard deviation divided by the square root of 15, right?
Yeah.
So we got 120.54 divided by the square root of 15.
Yeah.
And that equals 31.123.
Huh. I did on Excel. Maybe it's not as accurate or something. I don't know.
What did you get?
So I got, well, I just walked it through. So I got the square root of 15 to be 3.872983 or something like that.
Okay.
So then I divided 542.3 divided by what I just said. Am I right so far? Or?
Why are you doing 542.3? That's the mean, not the standard deviation.
Oh, yeah. Yep, that's why. I was like, man, I'm way off. That makes sense. Okay.
Okay. What is the probability the sample means the score of SRS is n equals 15 students greater than 600?
Wait, just to make sure, did everybody get 1.123? Yeah.
Mm-hmm.
Okay.
Yeah. 57 over 120.
So this is.
So isn't this that formula where it's 600 minus the mean divided by the standard deviation times the square root of n? And when we put that into the applet,
So if you go to question 27, that's what's the probability. Oh, no, I randomly selected student 4 seconds. Never mind. Yeah, so this is just that formula, or the x minus the x bar or whatever.
so okay.
And you subtract the standard deviations too, right?
You subtract the standard deviations. What?
On the bottom part of the formula,
I thought it was you times the standard deviation by the square root of n.
So I guess I thought it was x bar minus the u over the standard deviation over the square root of n.
1, 2.
No, you don't square anything. That's to find the
Z-score?
standard deviation of the sample.
Oh.
So now for the z-score, you do x minus the mean.
Yeah, which
So
is
it's
57.7.
Right, and then you just divide it by the standard deviation, which is 31.123, and then you input that into the applet.
Oh.
Okay. And you know what's hilarious? 120.45 divided by the square root of 15 is 31.123, which is exactly what I said. So yeah, the square root of 15 divided by, actually no, that's times. Yeah, you're right, divided by the square root of 123. Okay. Let's do this. All right, so in the applet, we put 1.854.
Yeah. And then highlight because it's greater than, you highlight the right portion.
The entire right portion, so 0.968. Oh no, that's above the minimum. So 0.032.
Yeah. That's what I got.
Yeah.
Okay.
You submitted?
That was long.
Yep. Ready to submit?
Yeah.
Yeah. Just go all the way to the bottom. Got an A.
Boom.
Looks like we did put 0 and 1 for that question 23 and 24.
What?
Oh, we didn't have to spell out 0 or 1 for 23 and 24.
Oh. I put in 0 and 1 spelled out and right, so
Oh, you did? I got it right too.
I don't think it matters then.
Oh boy.
So looks like we got them all right.
Man. Good job, guys.
Want to stop the broadcast?
All right. Yeah. Let me find it.